All right, we're continuing with section 1.6, part C. With this example, f of x equals the opposite of x squared minus 4x plus 5. We'd like to find all of the information that makes it easy to graph the parabola, the vertex, axis of symmetry, zeros and x-intercepts, and the y-intercepts. All right, so in this case, I want to start with my vertex. And we're going to use that formula that we just talked about. The x value for the vertex, x equals minus b over 2a. In this particular case, b itself is negative 4, so I would have minus a negative 4. Or really just a positive 4, of course. Divide that by 2 times a. Our a is actually negative 1. So I end up with positive 4 divided by negative 2. And the x value of my vertex is negative 2. To get the y value of my vertex, I'm going to take that negative 2 and I'm going to plug it back in for the x in the original equation. Or in other words, I'm going to find f of negative 2. When I do that, I'm going to get a minus sign, and then in parentheses, negative 2 squared. Subtract 4 times negative 2, plus 5. And as long as you use the parentheses the way we have them written, you can plug that right into your calculator, and it will give you the correct y value. Or we can also think this one through. Negative 2 squared would be 4, and then there's a minus sign in front of it. That's going to give me a plus 8 and a plus 5. 13 minus 4 is 9. So we've got a vertex of negative 2, 9. All right, once I've got the vertex, the axis of symmetry is actually easy. It's just the vertical line through the vertex. It's going to be x equals negative 2. Since I don't really need to do any work, I'll just go ahead and record that in the chart down here a little bit later. Let's go ahead and find zeros or x-intercepts next. To find the x-intercepts, we set y equal to 0. Y is the same as the f of x here. So I put 0 over there, equals negative x squared minus 4x plus 5. All right, I'd like to try factoring this. If that doesn't work, I can always use a quadratic formula. Let's see. Actually, I'm not crazy about factoring with a negative in front here. I prefer to have a positive. And so I'm going to multiply the whole equation through by negative 1 on both sides, just so that I don't have to deal with that negative. So 0 would equal x squared plus 4x minus 5. And I think this one is going to factor. Since I just have 1x squared now, I know that's x times x. And I'm looking for a sum of 4 and a product of negative 5. I think 1 and 5 will do that. If I make the 1 negative, I get the correct product, and they add up to 4. So x minus 1, x plus 5. That means x minus 1 equals 0, or x plus 5 equals 0, x equals 1, and x equals negative 5. Those will be my zeros. Of course, that means the x-intercepts, those are the x values for them. They'd have a y component of 0. I'll go ahead and list those again when we kind of get to the point of doing this little chart down here at the bottom. All right, let's find one more thing by hand, that being the Y-intercept. For the Y-intercept, we want to put x equal to 0. So I'm going to have y equals negative 0 squared minus 4 times 0 plus 5, which just gives me y equals 5. Notice again, we talked about this a little bit in the previous video, that c value, the last number, is always going to end up being your x-intercept after you plug in the zeros for the x's. The first two terms will always vanish. All right, so I'm going to go ahead and put this information in down here. We already know the vertex was negative 2, 9. And let's plot that on our graph. Right there. We also know the zeros, which correspond to the x-intercepts, are at 1 and negative 5. Which is actually enough to sketch my parabola right now, but I'm going to go ahead and make the y-intercept accurate here at 5. And then I'm just going to draw the shape of a parabola, like so. A little wobbly, but it'll do. All right, the axis of symmetry is this vertical line through the vertex. In this case, that goes through x equals negative 2. So its equation is x equals negative 2. The domain for a quadratic function is always going to be all real numbers. We can substitute any x value we want, right? I could put in any x value, positive, negative, 0, fractions, decimals, doesn't matter. I can calculate for any x value at all. So I'm going to write that in interval notation as negative infinity to infinity. The range, however, notice there are no y values that go above 9. 9 is the biggest y value. So I can think of my range as being y is less than or equal to 9, or we typically prefer interval notation. Y's go from negative infinity until 9, and then stop. I do actually hit the 9 at the vertex, so I'm going to use a hard bracket, closed bracket. All right, the zeros we had right here, x equals 1 and x equals negative 5. The x-intercepts are just these two actual points, 1, 0, and negative 5, 0. And the y-intercept is this point, 0, 5. So there's our complete graph of the function, analyzed as to all the interesting or important points about it.